it's sometimes useful to change the value inside a volume based on the existing value. We've already seen how to do this using the volume mix SOP. Another way to do it is using the volume ramp SOP. This allows you to choose which primitive you're working on, and if necessary rename it, which makes more sense if you're converting it into a color, on which more in a moment. The controls below allow you to remap the range of values of your volume based on the existing values. This is best demonstrated by laying down an ISO surface and creating a volume that goes from 0 to 1 along its height, which we can do by putting $y plus 1 times 0.5 in the formula. Now when we play with the spline, we can see that the volume changes. Another use for the volume ramp SOP is to change a single value volume into a vector, or in particular into a color. If we rename our value CD, which is the standard name for color, and tick the Use Color Spline option, we will end up creating 3 volumes containing red, green and blue color information. The colors will be created by feeding the incoming volume into the color spline. So if we adjust this, we should eventually see a multicolored volume. The colors won't show up unless we render, so let's lay down a camera and a light and a mantra node and assign a smoke shader to our object. Another way to manipulate values inside a volume is to use a volume VOP SOP. Let's lay one of those down, a volume VOP SOP, and it's giving us an error and it can't find a name. And this is because by default our ISO surface doesn't have a name, so I need to insert a name SOP here, and I'm going to name the 0th primitive. There's only one primitive coming in, and we'll name it myvol, and our error now disappears. Let's jump inside here. Let's enlarge this first. Let's jump inside and see what we have. We have a set of global variables here and an output, and by default it's just taking the value of density and feeding it straight into the output. Now if our volume was called density, we'd just be able to add some code here and feed the value back out into density. Our volume is called myvol, and so there are 2 different things that we could do to allow the volume VOP SOP to change our data. One of them is here on the SOP itself. I'll bring up a parameter pane. If we have a look at volume bindings, by default it's set to auto bind by name. In other words, the name of our volume, which is myvol, needs to be used as a variable inside the network here, so we would need to bring in a parameter called myvol. Alternatively, we can set a binding here. We can say that primitive 0, there is only one primitive coming in, so that's primitive 0, could be bound to density. We'd then be able to do our calculations based on the variable density inside here, and the result will be fed back out into our volume. But I'm going to demonstrate the other method, so we'll put that back to its default. We'll dive in. And I'm going to need a parameter node, and I'm going to call this myVol in, and then the parameter name is going to be myVol, and we're going to make it invisible. And I need to create a duplicate of this, so I'm going to Control C, Control V, and let's bring up a parameter pane again, and this is myVol out. Now, by default, you can't set parameters on two parameter nodes, which refer to the same parameter. You'll see here we're allowed to set all these values, but here we're not. But in fact, it's on this node that we want to set them, so we need to tick this tick box, which allows us to set the values here, and on the out value we need to set export to always. And I've made both of these invisible, so they won't show up in a parameter editor. Now, as a very basic example, I'm just going to lay down some turbulent noise, and I'm going to feed the position into the position, and I'm going to lay down a multiply node, and multiply the result of the noise by the value of myVol. And then we're going to feed the output into myVol out. And the result of that should be that the values in our volume will be multiplied by the noise. Now we can check always whether what we think should happen is happening by right-clicking on any of these nodes and looking at View Vex Code. And if I go right down to the bottom, what we should find, there we are, is myVol equals noise times myVol. And that's what we want. So we should find, if we go back up to the SOP level, that we're getting a noisy volume, and indeed we are. If you want to render volumes, you have to use a specially written shader. This is because, unlike normal surfaces, which are diced into little tiny polygons during the render, micropolygons as they're called, and then the micropolygons are run through the shader, in the case of volumes, these are diced into little tiny boxes, microvoxels if you like. And by the way, the microvoxels are usually much smaller than the voxels that exist in your volume primitive. So the shader has to understand that it's dealing with a three-dimensional input, a box, not a flat micropolygon, something that has dimensions not just in x and y, but also in z. And it's the dimension in z that is vital to calculating the opacity of the microvoxel. Now, exactly how this is done, how the opacity is calculated, is beyond the scope of this tutorial, but the topic is covered in detail in the Mantra Masterclass on the Side Effects website. The short answer is that it's much easier to modify one of the existing shaders here in the volume section than to write your own.